In this video, we are going to tackle about a solids of revolution. So I have a short explanation about a solids of revolution. It talks about a three-dimensional figure and has a volume. And for calculating the volume, we have a three elements method that useful. First, we have here the Des method. Second is the washer method and the shell method. So we focus only for the application of this method using by definite integral. So before we proceed for this method, I would like to show the example of solids of revolution. I have here the solid matter or object. So it represent, or this would be considered as a solids of revolution because it has a three-dimensional figure. And we have here the volume, and we can calculate the volume here by using the three elements method. So for the first method, which is this method, I have here the short explanation about for the Des method. So it has a one radius, and for getting a radius for the Des method, top minus bottom. So, and also this method is useful for calculating the volume that only a single curve that rotated along the x and y axis. So rotated along the x and y axis. So that is for the Des method. And we have also the formula for the Des method. It depends upon the axis of rotation. So if the axis of rotation is in the first is in the x-axis, so the volume is given by v is equals to pi times the integral f of x raised to the second power dx. The a and b here represent of our limits of integration. So y as dx because the function here, it talks about in terms of x, and the axis of rotation is occur in the x-axis. So for the key points, we have here radius is equivalent to the value of our f of x. Take note, and the f of x is equals to the value of our y. So let's, for the second case, if the axis of rotation is in the y-axis, the volume is given by v is equals to pi times f of y. Y is f of y because the axis of rotation occurs in the y-axis. So with respect to y raised to the second power here, f of y raised to the second power, and then dy. So c and d represent our limits of integration, the same with e and b. So for the k points, radius is equals to the value of our f of y, and the f of y is equals to the value of our x. Always remember for calculating the radius that top minus bottom. That for the radius. So it is clear, and for now let's proceed to the case problem. So for the case problem number 1, find the volume of the solid obtained by rotating about the x-axis. Take note, the region under the curve is y is equals to cube root of x squared from 0 to 2. So supposed to be the 0 and 2, let the value of our e and b. So let's have a graph. I have here a graph in order to more understanding and for more info. So we have here, so for the axis rotation occur in the x-axis. We have a graph according to the problem we have here. So the arrow here is for the along the x-axis. So if we rotate this one along the x-axis about 360 degrees, what will be happen? So we have here the y that represent of our the value of f of x and our radius. So our radius is x cube cube root of x squared. So this would be our radius because top minus bottom, the bottom here is equals to 0. So the result is x cube cube root times x squared. Cube root of x squared, sorry, x cube root of x squared. So if we rotate this one according to a case, rotate along the x-axis about 360 degrees, we can form a three-dimensional object. So we have here. So at this moment, we can calculate the volume through by a given problem, which is the integral v is equals to pi times the integral of f of x raised to the second power dx. So let's have a solution of this one for the case number 1. So we have here the volume is equals to pi times the integral with the upper and lower integration limits of integration, so a and b, in terms of f of x with respect to x. We have here the secant power here. So that would be the formula for the case number 1 here. So try to look and analyze this one. So let's substitute the value, and suppose y is equals to the value of f of x. So for now, the f of x is cube root of x squared. So, and then the 0 to 2 is r, e, and b. So let's substitute. This will become b is equals to pi times the integral of cube root of x squared raised to the secant power with respect to x, with the lower 0 and the upper 2 represent of our limits of integration. So for now, in order to easy to simplify, we need to convert this one into a exponential function. So this would be v is equals to pi, and then we have 0 to 2, and then the integral of let's convert into the exponential. This would become x to the 2/3 raised to the secant power with respect to x. So at this moment, there are two types or two techniques. First is we isolate this one into the x to the 2/3 times x to the 2/3. But for me, I am prefer that this exponent here, I multiply to the 2 here. So 2/3 times 2 is equals to 4/3. So this would be b is equals to pi times the integral. We have 0 to 2 here, and then x to the 4/3 with respect to x. So let's integrate this one. So the integral of x to the 4/3 is equals to v is equals to pi times the function that is already the integral of this one. So x raised to the 7 over 3, and then 7 over 3, because we add this one plus 1, and then what is the exponent, that would be our new denominator. So 4/3 plus 1 is 7 over 3. So evaluated 0 to 2, and let's simplify this one, 7 over 3 into 3 over 7, and let's put replace this one from this one into this place. So this would become b is equals to pi times the function 3 over 7 with x 7 over 3, evaluated 0 to 2. And for now, we can evaluate the 0 and 2 of this function by using the principle of definite integral. So if we have b f b minus f a, f here represent of this function, and then b, this is already the value of our 2, and then e is 0. So let's evaluate this one. So this would be v is equals to pi times the integral of this function, which is 3 over 7, and then we have 2 raised to the 7 over 3, and then minus, let's evaluate 0 of this function, becomes 0. So the result is 0. Evaluated this function. So for now, our concern is this function. So for me, I am prefer to simplify this one, that 2 to the 7 over 3. I am I will convert this one into a radical function. So this would be v is equals to pi times the function of 3 over 7, and then becomes cube root of 2 raised to the 7 power. So for now, we can easily to simplify this one. So 2 to the 7 is 128. So for the volume for now is b is equals to pi, and then 3 over 7, and we have the value of cube root 128. So at this moment, 128 is not a perfect cube. So let's factor out this one, that one of the number is a cube root, perfect cube root. So this would be 16 and 8. So v is equals to pi and times 3 over 7, and we have the value of our cube root. For now, let's factor 128 to 16 times 8, because 8 here is perfect cube root, so we can replace out of the radical sign. So the cube root of 8 is equals to 2. 2 times 3 is equals to 6. So the v is for now is v is equals to pi, and then times 6 over 7 coming from the cube root of 8. So times 3 is 6, and then the remaining inside the radical sign is 16. And then for now, we can simplify this one, that 16 becomes, we need to factor out this one, because 16 is not a perfect cube root. Perfect cube root. So let's 16 is factor, the result is 8 times 2. The 8 times 2 is 16, and the 8 is perfect cube root. So 8 cube root of 8 is 2. So let's have b is equals to pi, and then we have 6 over 7 cube root of 8 times 2. 8 here will replace out of the radical, so becomes 0, becomes 2, sorry. So 2 times 6 is equals to 12. So b is equals to pi times times this function, 12 times the cube root of 2 over 7. We have here over 7. So for now, we is no longer to simplify, except for convert this one into a decimal function. So if we convert this one by multiplying this pi to this function, you will get v is equals to we have 6.79 units cube. So for now, this would be the volume of this figure, that the rotation occur in the x-axis by a given that y is equals to cube root of x squared, and we have here the interval of 0 from 0 to 2. So it is very clear, and let's proceed for the second case, which is with the same function. We have here, with the same function, find the volume of the solids that the axis of rotation is in the y-axis. So in the first case is the axis of rotation is in the x-axis. For now is in the y-axis, using this with the same function. So for now, let's have a graph in order to figure out. So we have here a graph. So instead of the rotation is in the x-axis, we are now in the y-axis. So instead of y is equals to cube root of x squared becomes y to the 3 halves. Because we need to convert this one. We have here. So from the x-axis, we have the value of our y is equals to cube root of x squared. This is for the x-axis occur. For now, we have here the y-axis. So let's convert this one in order to get the value of our x. So how can we simplify this one? So we need to y is equals to cube root of x squared. We have here. So let's multiply into the 3 halves. Both side 3 halves in order to get the value of our x. So this will be cancel. So cancel, and then x is equals to y to the 3 halves. So that's why our x is equals to y to the 3 halves. And then if we are going to rotate this one around the y-axis about 360 degrees, what will happen? So we can form this one, a 3-dimensional figure. So for now, we can get the volume through by a given formula, which is V. We have here. So let's have here. So the axis of rotation is in the y-axis. So let B is equals to pi times the integral. We have here the C to D. So let use the variable C and D by represent of our limits of integration. And then we have here in terms of y. So f of y, we have here raised to the secant power and with respect to y, because the axis of rotation occur in the y-axis. For now, remember the f of y is equivalent to the value of our x. So our x, that would be our radius. Remember that from the curve here, minus to the bottom, top minus bottom is equals to this one, because the bottom is equals to 0 here. So that's why x is equals to y 3 halves. So for now, let's substitute that the x here equivalent is y to the 3 halves. That would be our f of y. So y to the 3 halves. And then c to d, we have here the interval with the same 0 from 0 to 2. So let's substitute. Let our 0 here is c, and then d here. Our the d is 2. So we can evaluate now. So this would become b is equals to pi times the integral. We have the lower limit 0 and then upper limits 2. And then the value of our f of y is equals to y to the 3 halves and raised to the secant power with respect to y. So it has two types of simplification, this one. So I am prefer that I convert this one into a radical function. So this would be v is equals to pi, and then we have 0 to 2 here, and then the square root of y raised to the 3rd power and then raised to the secant power with respect to y. For now, we can cancel 2 here and then the square root here. So the remaining is, we left the expression as y is equals y raised to the 3rd power. So for now, the volume is equals to pi, and then we have the integral y to the 3 with respect to y, and we have the upper and lower limits 0 to 2. So for now, we can integrate this one. So the integral of y to the third is v is equals to pi times the integral of this function is y to the fourth over fourth evaluated 0 to 2. For now, we can evaluate this one by using the definite integral principle. So we have f here represent of our this function minus fa. So the value of b is 2, the value of a is 0. So fb minus fa. So let's y substituted by 2 to 2 to the fourth, and then we have fourth minus minus 0, because if we evaluate 0 of this function becomes 0, because 0 to the fourth, 0 over 4 is 0. So the volume now, if v is equals to pi times this function, so we can simplify this one to the fourth as 16 over 4. So the volume now is equals to pi times 16 over 4 is 4. So 4 pi here, because 4 times 4, pi times 4 is equals to 4 pi. The volume is 4 pi, and we can simplify this one, we can convert this one, the decimal, we can get the value of how much, 12.57 units cube. So this would be the volume of our figure that rotate along the y-axis. So the volume now is 12.57 units cube. So thanks for watching, and don't forget to subscribe the Freelance 57 channel for more updates.